right. So just to start, I have a bit of a confession to make. I'm not good at all with cars. Changing a tire on a car that does not move, that's as far as I'm willing to go. So today we're really going to talk about the software version of this, is how do we do this when our software is moving and we actually want to change things. This page, Populo, the company I work for, Populo is currently down for scheduled maintenance. This is like a year ago, like as far as a year ago, this is the type of page that our users would be presented to. Okay, sure, maybe it's with 7 days notice, it's scheduled. Sure, maybe it's only for 2 hours on a Sunday evening. Okay, maybe that's okay, maybe they're actually happy with that, but as we actually go and grow as a company, grow as a platform, so Populo, just to give you a bit of context, Populo is an internal communications platform. What we do is we provide software as a service for large companies distributed around the world to help their employees, their internal communications departments to communicate with their employees, drive communication campaigns, engage their employees to improve their happiness, the way they stay in the company, and their productivity. So this is things that are actually used globally for now maybe up to 15 million employees around the world that are being communicated to using this platform. But yet, we were kind of thinking, sure, it's a Sunday night, we've told them, who cares, right? But maybe you remember the earthquakes in New Zealand. One of the many earthquakes in New Zealand. I remember the last one quite well because I have family living over there and they were sending us videos from Christchurch in the night with blaring sirens for tsunamis. And this is where we kind of realized that this is going further than just employee communications for say, hey, here's the lunch menu, or here is the latest TO message. This is actually communications that are going to employees for safety reasons. So here, some customer in New Zealand wants to provide regular updates for their employees to maybe say, well, don't leave your house. This is not safe. Stay home. Don't come to work. And this is not the only example. I have one of the colleagues of mine who had a meeting with a customer recently who are based in, having an office based in Sri Lanka where there was recently terrorist attacks. Some of their employees actually got killed there and they had to communicate with people. So it's like, whoa, we think we're actually building a software that's just a supporting tool for their employees. This is much bigger than that. And when we're in a global scale, this is just simply not acceptable. This is how can we function as a company? So my name is Pierre. I work at Populo as an infrastructure and reliability manager. Most of my work is actually enabling work for product teams to make sure that they can deliver value fast, they can deliver value reliably and sustainably, very much in line with some of the stuff that Manuel would have talked about yesterday. So a bit of a history lesson on where we were in terms of that continuous delivery and that downtime aspect. I've been working at Populo for more than 10 years, so I've seen all those changes from the inside, from a team of 5 developers now growing to upwards of probably 100 this year. 2009, 10 years ago, we were deploying every 3 to 6 months, and that's pretty arbitrary. We were just saying, hey, something is ready, let's go and deploy. The downtime was about 4 hours. We were doing it on Sunday afternoon. Our customer base wasn't so big, so maybe it wasn't so much of a big deal. As we grow, and as we grew as a company, we started seeing more teams, more changes coming in, and even though we were only starting to see a bit of the DevOps practices, we really had that gut feeling that, okay, we need to reduce our batches there, releasing every 3 to 6 months. This is way too risky. So we reduced that all the way down to 4 weeks. They reduced down a little bit of downtime, less changes, less database migrations, and ultimately we kind of even moved the time a bit later in the day because the upgrades took a bit less time. This is valid for our core monolithic application, which is most of our system still today. In the meantime, we've also experimented with microservices, which is for all our new features, and we actually discovered the value of zero downtime at that point because we were saying, hey, with microservices, with Docker containers, with all the stuff that orchestration gives us, we can get zero downtime, we can deploy multiple times a day, on demand, nobody notices. Wouldn't that be great if we could do that for everything? But we're talking here about 8 to 10 years worth of development that had gone into a monolithic application as you probably all know, you can't just click your finger and just convert that to microservices. So I'm going to talk mostly about our journey for the core monolith and how we actually got there. So this is DevOps Conference. I think almost contractually obliged to mention State of DevOps Report or Accelerate, like the absolutely awesome work from the team led by Nicole Forsgren on basically the science, like sciencing the hell out of DevOps. And one of the really, really valuable things that came out of it is it's very, very clear, and the data proves it, that high-performing organizations deploy way, way, way more frequently than the low-performing ones. So what we wanted to do by releasing faster, there's actually data backing it up saying, yeah, the ones that are good, that's what they do. So we wanted to get there. But then we have that kind of paradox. We want to deploy much faster, but every time we want to deploy something, it takes us 2 hours of downtime for our application. How does that work? How do we do it? We know there's value in smaller batches. We know there's value in reducing risk, but we can't do it because obviously there's that downtime. And it still is the elephant in the room, because there's a funny thing about Populo is that it's a really, really good place to work. And the side effect of this is people stay. So a lot of people that built the application 10 years ago, they're still there. And when you're there for a very long time, then you kind of put up with things for a very long time. It's like, well, sure, it's always been that way. We've always deployed the code that way. We've always built it that way. And it kind of becomes the status quo. So basically, every time we talked about zero downtime, it was like, oh yeah, sure, like that would be absolutely awesome, but we can't do that. The architecture doesn't allow it. It's way too monolithic. It's way too tightly coupled with the database. And a lot of stuff that would be like, okay, yeah, sure, it would be great. Maybe we'll do it next year. And one day, our head of engineering, who's my boss, went to talk to me and said, I want us to get to zero downtime. Tell me what we need to do to get there. And it was kind of eye-opening, saying, that's actually not impossible. He's telling me we need to go and do it. Let's go and look at it, really for clearly what it is. So that's what we did. We actually got everybody in the room from a lot of the different functions, so people from the SRE space, from the operations space that would be doing the deployments, from the product teams, from support, who would actually be communicating those updates and that downtime to customers. And we started using value stream mapping to say, okay, what do the deployments actually look like? What's happening? At what time? What is happening in parallel? What are we waiting for? When are we telling things to customers? And the funny thing is, after 45 minutes of that single session, we were like, whoa, we can actually do this. It's like we've been talking about it for years, and maybe by doing this thing here, moving this thing there, actually, this is actually possible. And the big aha moment of that session was to actually realize that there's a big difference between downtime and perceived downtime. You can still take things down, and I'm going to go through that further on in the talk. So long as people don't notice, then this is fine. So I'm just going to present to you there some of the output of that mapping session, which is really purely on the impactful state of the deployment. Because what we really wanted to realize is what's the steps that are taking impact to the users, and we want to reduce that as a priority. So the way we deploy our application is we kind of have a maintenance mode session, which is basically kind of a degraded mode for the application for kind of wind down of long-running jobs. Depending on what's actually happening in the application, once we flick that switch, it could take between 5 and 30 minutes for this to happen. And during that time, the impact is the user can log into the app, can do most things, so let's say using the content management, create content, but maybe not be able to publish it, for example, this type of actions. Once all of that is drained, we can shut down the services. We run our database migrations. So that, again, 15 minutes to an hour, depending on every deploy or every release. That could be different. And this is actually quite problematic because we can't really know in advance, depending on the data. Upgrading the services. So now we have just literally getting RPMs on machines. A lot of that would have been manual at that stage, SSHing to machines, uploading RPMs, do updates, etc. start the services, and then wait for them to actually be started up. When everything is confirmed to be back up, disable the maintenance mode, and then everything is actually fine. All of that taken in or around 15 minutes, right? And that entire phase there is downtime. So that page that I showed at the start, that's what users are seeing. We're actually currently down for maintenance. There is much more complexity in each of these different steps, right? But by looking at this from this level, we were actually able to prioritize and see, oh, right, okay, it's not just zero downtime as like, overnight, we're just going to go from 2 hours to nothing. Let's go and say, can we incrementally reduce the impact? What if, maybe we'll never get to zero, but if we got to 15 minutes, that would definitely already be better than 2 hours. So from this, we actually prioritize a list of tasks, the first of them being database. Why do we need to turn off the application? Why do we need people to be away from our application when we actually want to migrate the code, migrate the database? So that was our first priority. Let's try and keep the application up, migrate the database before, or out of sync with the application itself. Ken touched on that this morning. It's about decoupling and decoupling the database schema versions and the application versions. There's a few rules for actually doing that and migrating that database online is, well, first of all, decouple. You can't have the application assuming that the database version is perfectly in sync with it, which what we had. And there's a funny thing that we discovered throughout that process is we even had implemented strict assertions so that the application would not be able to run with another version, just so that we, not by mistake, we would not migrate the database and run the application in another version. And for a lot of people that would have seen that assertion, they'd be like, well, sure, we can't do that because it's there, not even questioning why the assertion was there in the first place. So we were kind of tying our own shoelaces by actually having something that didn't need to be there anymore. So that backward compatibility, essentially, you want to be able to have the old application able to run in the new database, or new database schema. The next thing is, obviously, if you want that backward compatibility, any change that is made needs to be non-breaking. Non-breaking is pretty simple. Do not destroy anything in the old schema. No destructive operations on tables or columns, so don't delete tables, don't rename columns, don't change column types, all that kind of stuff. But only for things that are in use. If it's not in use, that's fine. Nobody's actually going to care. And that's the key point here, because you might say, well, I can never rename a column, or I can never delete a table. Well, sure, you can. These are typically what looks like breaking changes, but you can use patterns like expand contract, which I'll explain in a second. Again, Ken talked about it this morning, probably for about like 3.5 seconds within all the content that he gave. So, and then the next thing is, well, you're actually now talking about losing the safety of having the application down while we're actually migrating the database. Now, the database is still accessed with live traffic while we're actually running those scripts. So all sorts of locking problems, depending on the type of database that you have, or like if InnoDB is a bit better, but there's still a few risks here and there depending on your table types. So what we did for this is we actually, SRE wrote a tool that actually checks the types of scripts and the types of operations that are done inside the build pipeline, so that immediately in the build pipeline, the pipeline would block if you're saying, well, it looks like you're going to have a locking change. Are you actually happy that this is going through? Maybe it's a tiny table, maybe there's not much data. We're happy that, okay, a lock for a second is not that a problem. We don't have massive amount of data, so for most of the times it's okay. But we got burnt by thinking best practice will be enough, but it actually isn't, because now we actually have a way to check. So I mentioned expand contract. A very, very brief example of this. Let's imagine you want to rename a column, first name to, or suppose last name to surname. Instead of renaming it directly, we're doing it by phase. First of all, we create a new column with the new names. And we write, so dual write mode, write to both columns. Then we migrate the records that would be historical. Once all the historical records are migrated, then we can actually read from the new column. The old column becomes obsolete, and we can remove it. What does it look like in terms of releases? Is that's going to be scattered around 3 releases. First release, introduce the dual read, the dual write. Second release, migrate and start reading from the new one. and then that kind of clean up release, now delete what's obsolete. The important thing is not to forget that cleanup one, because you have already 2 or 3 releases behind, and it's like, oh, now I've moved on to build something else, and suddenly there's tables with weird columns that nobody remembers. So this is a bit of a little bit of a dance, but that allows you to basically have those scripts that are going to be efficient and are going to be just gone through all those releases. Schema migrations and zero downtime schema migrations is like something that you could probably spend an afternoon on, so there's a lot more resources on there. I'll share the slides later if you want to have the links. So really, really good ebook from Baron Schwartz from Vivid Cortex about this, full chapter on loosening that coupling between the app and the database. There's a talk as well from Michel Rook from, that was the continuous lifecycle in London, again, about how to use tools like Flyway and for database migrations and that kind of expand contract examples as well. So, okay, database out of the way. We can upgrade our database a few hours before our applications, or a few days. That's actually not a problem anymore. Now, on to the next question. Why do we need to turn off the application to upgrade the application? Which seems pretty valid, like when you think about it. But then we kind of started thinking, well, we're using Kubernetes for our microservices stack, and there's that cool thing called running upgrades or running updates. Can we try and do that with our old monolithic stack and the different processes that we have there? Well, I think we can. So the example of what it looks like to do a full running upgrade is, well, first of all, you need to have 2 of whatever you want to run. If you only have 1, then obviously you have to take it down before you need to bring it back up. So this would be the way we would have done before. Full upgrade, you have, let's say, 2 instances. That works the same way if you have 5, if you have 10. Running version N, and we just start saying, well, okay, let's go and shut it down. So maintenance mode, we drain the remaining work, we stop the processes, we upgrade them, we start them, and they're back up again, version N+1. Pretty standard, pretty typical. But then now we have a whole period of time where we have a feature downtime. People are not able to maybe send emails or trigger mobile notifications to their employees. What does it look like for a running upgrade then? Well, we still have our 2 instances. It looks the same for the first one. We just go and say, okay, drain, stop, upgrade, start. But the trick is to not do that at the same time for the second one. And the way we do it is we just keep it up until we're happy that the first one is actually ready to go, and then we just move on to the second one. What it means here is like we have continuously available feature throughout, or functionality throughout the upgrade. That works the same, again, if you have 5 instances, if you have 10 instances, you can do 5 at a time, so long as there's at least something that's going to be serving traffic. Now, you have to be careful of the amount of capacity that you need, the amount of redundancy that you want. So if you want to, instead of going 1, 2, maybe you just had 3 and add a third one temporarily. There's a lot of techniques that you can do with that. For us, and that might be different for others, but for us that actually works because that phase is actually pretty quick. So that actually got us most of the way, because now we can actually run database migrations out of band. We can upgrade all our different processes in running fashion, so we don't actually have the downtime of any of the features provided. But we still got into a bit of, I suppose, the scary moment of, okay, wait, now you mean that we're going to be running upgrades with users in there? Upgrades were already scary. They were already scary when we were running them when the system was off on a Sunday. And our operations team, who are rotating that role of every month, just picking that thing, it was getting to a point where you could see the despair of the person figuring out, oh, that's my turn. It's my turn to do the upgrade tonight. Like, this is Sunday at 8 o'clock at night, but I'm going to be thinking about it for the entire day. My Sunday is ruined. My weekend is ruined. Like, I hate my job. So this is because, and I say we all felt that, that kind of feeling at some point. And this is because big deployments are scary. They're stressful. And why are they stressful is because we actually put too much emphasis on manual operations and tribal knowledge, or things that, oh, I have to remember to do this and that. So what we wanted to do here is, We wanted to remove that stress, because that stress is a symptom of a bad process. We wanted to make those deployments repeatable, consistent, and visible and observable so that we can actually have something that whoever is going to be doing it, especially if now on top of it we're keeping the application up, we have traffic, maybe we want to doing it during working hours, and without even telling people that we're doing it. That's okay, that's a really, really big jump. So first thing our operation and SRE team was say, well, so far we have everything in source control, apart from that part when we just copy some of the things, and doing rolling upgrades, much more complicated than actually doing something like turning off everything, upgrading everything, and turning it back on. What we did is, by using the GitLab pipelines and Ansible playbooks, we got basically everything in the pipeline in source control. That means there's one button press, and that's actually one of the pipelines for some of our front-end applications, to give us really consistency and repeatability in our deployments. There's nothing in there that's like, oh, I'm copying and pasting something from a Word document. I'm not SSHing into a machine to do something. Literally everything is there. And then the bonus is everything is as code. Everything is inside a repo. You can actually see the changes. Those changes are code reviewed. Those changes are tracked in history. And then that stress of actually making a mistake in that moment of a bit of pressure, it's off because it's a button to press. You know that process has been vetted, and you know whoever is going to do it, it's going to be the same thing. And then the stress also meant that from even pressing a button, it's like, what is actually happening when that deployment is running? Like, there's a lot of stuff behind the scenes. So we're running database migrations. How is that affecting users that are running live? We're running rolling upgrades. How is that affecting capacity for the applications on their upgrade? And how far has the upgrade gone? So the observability of our deployments became really, really important. And so far, the main way was tailing logs in a few places, SSHing into some machines, or literally just kind of F5ing the applications. Like, is it still up? Is it still up? That's just not acceptable for a process that could affect a lot of users. So this is an example of how we use Prometheus and Grafana, and also behind some elk stack for some of the logs. Displaying core health checks of basically our synthetic journeys, rolling upgrade process. So you can see, I'm not going to go through the details, but you see that in red and green, and those lines at the bottom just show how far it is, error rates, saturations of queues, all those kind of really important metrics that they tell you if things are going well or not, and then they become jumping points for saying, okay, there is something now, I have a runbook, I can just go and say what's going on next. So looking back at that picture that we had at the start of, okay, we're deploying every 3 to 6 months, going back to, okay, now we can try and go and deploy every 4 weeks. Every 4 weeks is okay, but that's as far as we could go because of the downtime. And even though it was on Sundays, it was still impactful because we were becoming a more and more global company. We're based in Ireland, but Sunday night in Ireland, this is Monday morning in New Zealand. So you're always going to be impacting somebody. And in terms of work-life balance as well, for that particular person that's going to be doing it, maybe so there's somebody in operations, there's somebody in the product team that's going to be there to do some validation behind it. That's not great. It's not great to working out of hours when it's, for emergency purposes, that's fine. Here we're asking people to work out of hours for systematic processes. That's not great. So where we got so far in 2019 now is that application, that monolithic application, got raised to the same level as we have for our microservices stack, which shows that we actually did not need to re-architect our monolith to microservices to get the similar benefits that we wanted. We didn't say, oh, if we want continuous delivery, continuous deployment, and zero downtime, we need to do microservices. It's like, no, there's a few things that you can do on a monolith that actually get you the same amount of value. What are you after? Are you after microservices, or are you after continuous delivery? Microservices are one way to get there, but you don't have to re-architect everything, and don't believe people that tell you that you have to. So we can deploy anytime, zero downtime, and during working hours. That's when we're actually doing it now. And it had a lot of really powerful outcomes as well. Work-life balance, less stress for whoever is doing the upgrades. Now it's kind of like, oh, it's my turn, that's fine, sure, I'll do it. That's at 9 o'clock in the morning. I know everybody's going to be there. I know if there's a problem, somebody's going to be able to help me, instead of me having to ring somebody and find somebody else on a Sunday night. And it also had kind of side effects of value as well. Recently, there was another kernel vulnerability that came out. When it was Spectre, like 18 months or 2 years ago, this was like a big undertaking for us to upgrade our stuff. And the fact that we changed all those processes, we got to a stage where now we could have patched that vulnerability during the day, and ops were on the Monday morning saying, oh, I think we need to patch that vulnerability, it's going to be hard. And by the Monday evening, we're like, oh, that's fine, we did all production. It's like, oh, okay, it took us 2 weeks last time. So just in closing, I just want to kind of reiterate that aspect that we were really, really scared of doing this. It was, or we were averse to doing it because we were thinking this is going to be a really, really big job because we can't re-architect our stuff to microservices, or we can't decouple everything that we want to, until we realized that even on a monolithic architecture, you can still do it, because the deployments are the downtime is really a user perception. The downtime is, are your user able to do what they're paying your service to do? It doesn't mean that everything behind is actually staying up. It doesn't mean that everything that you have run the same version. It actually means that people don't notice while all of that stuff is happening in the background. That's me. Thanks very much. I think I might have time for questions.
Okay.
Hello. Great
Hi.
talk. My question is, when you apply database changes and then you said that if something was not being used, you could drop it.
Yes.
But what if you need to roll back if something goes wrong?
Okay, I'll just say the same thing that Ken said this morning. Try not to have to roll back. And typically, if you get to a stage where you're going to be dropping that column, it's not going to be in use anymore because you have a dual write. It's been written somewhere else already. So, in my experience, we didn't have to do that. But look at it before. If you wanted to change the type of a column or rename, I suppose renaming column is a different thing, but it's the same problems as you would have before. Like rolling back that change is the same problem as if you wanted to roll it back anyway. So either you keep the data around for longer, if you're saying actually I want to keep this for an extra couple of weeks for doing my cleanup. I say it might vary, but ultimately you should have your plan should make you that you don't have to do that. I think.
Okay. Another question? I think they believe in you.
Okay. Okay.
Or not. Okay.
Thanks very much.
Thank you.